Financial support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio we have Anna with us. And Anna, if somebody wanted to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357, toll free 1-866-636-6284. Emails dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Well done. Why don't you let everybody know where you go to school and what grade you're in?
I go to Ronald Reagan Elementary and I'm in 6th grade.
6th grade going pretty well so far?
Fine.
That's fine. Have you been at Reagan for a long time?
Yeah.
Since kindergarten? Oh, so you're getting ready to go to junior high school next year.
Yes.
What do you think you'll miss from Reagan? Or you won't miss anything?
Nothing.
Nothing? You ready to move on?
Yeah.
All right, well, good. You know what? Do you know why you're here today?
To get math help.
To get math help and to do some math, and it's time now to do some math. Are you ready?
Yes.
All right, head on over to the board, young lady. So you and Scott are going to work with a little bit of exponents.
Okay.
So can you first of all explain or show Scott anything that you know about exponents already?
So an exponent is basically like a number to the power of something.
Show me.
So like
What do you got?
5 cubed is 5 times 5 times 5.
Good, okay. So this tells you how many times to write that number.
Yes.
What do you call this number in math vocabulary?
The base.
The base, that's it. Good. So we want to make sure we're talking about the same words. What about this 3? What do you call that one?
The exponent.
Exponent, good, okay. Yep, so we have at least some vocabulary that we can work with there. And again, you're drawing it all out, and that's, I think, going to be the key for working with exponents, is being able to draw them out. Good starting place.
Good. So what I'd like you to do is, Scott, go ahead and write 5 to the third again.
Okay.
But now the third, I need a negative symbol in front of that exponent. So now, Anna, what do you think you would need to do? If you need a little help, Scott's right there for you.
Have you seen negative exponent?
Yeah, so
All right.
you're going to have to turn it into a fraction.
Okay.
So it would be 1 over 5 to the third.
Good. So changing this right here just to that takes care of the negative, right? Because you want to be able to write it without negative exponents. Good. So that's the first step. And then what would you do from there?
That's already simplified.
It is simplified, but I mean, if you wanted to write this problem with no exponents, what would you do from there?
Do 5 cubed.
Show us.
So it's 25.
So you're multiplying 25 times 5, because 5 times 5 is 25, and then you have another 5, 125. Okay, so what would be the final simplified version of this problem here?
1 over 125.
1 over 125, good. You could have 1 over 5 to the third power. You could have 1 over 5 times 5 times 5. Or you could have 1 over 125. All of those would be acceptable answers, right? But it's nice to be able to write this problem with no negative exponents. That's the key. Good, that's a good start.
There you go. Nicely done. Great start right there. Hey, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News has to actually do with something that happened a week or so ago, the Super Bowl.
Okay.
So you remember this happening, right?
Yeah.
Okay. I don't think, have we talked about the Super Bowl since you've last bit
Just a little bit. We had a number where all the factors
Oh, that's
added
right. We
up
were
and
doing an abundant number
an
that day.
abundant number, yeah.
All right. So do you have any idea what an abundant number is?
No.
Well, here's what you do. When you go home, you can look on YouTube. All right. We'll give you the address and all that stuff. And look for last week's program on Tuesday, I believe. And we talked about an abundant number right at about this time of the program, so you can figure out what an abundant number is, okay? But we're going to talk a little about something different today, all right? So, did you watch the Super Bowl?
Only part of it.
Only part of it? You got sick of it, or you have
No,
other
I
stuff
had
to
to go
do?
somewhere
Oh,
else,
good.
yeah.
I only watched part of it too. I only watched the second half. I had stuff going on during the first half. Anyway, Super Bowl 54. So we can see that if we take the number 54 and we put it in prime factorization, we're going to have 2 times 3 times 3 times 3. Now you know how to factor numbers, right?
Yeah.
Okay. And we see that, so read that bottom line for me. How would we read that?
2 times 3 cubed.
2 times 3 cubed. Perfect. Just like you were working on with the exponents, right? Okay. So that, I go, all right, well, that's a little bit of news. Now the 3 is cubed or raised to the 3rd power to make 27. This leads us to Brexit. This is our news, okay, along with the Super Bowl. Now, are you aware of Brexit, what that is and what's going on?
No.
No? Okay. Well, here's what you watch the news every once in a while. You're going to learn about Brexit, okay? All right. So anyway, on June 23rd, 2016, 52%, so just enough to get the vote, 52% of British voters chose to leave the EU, the European Union, a governmental organization with 28 countries. As of February 1st of this year, the UK will leave. They have left the EU, and the EU, the European Union, is now a perfect cube. Does that make sense?
Right.
Because 3 cubed is what?
3 times 3 times 3.
And what does that equal when we put it all together?
27.
27. And there are 27 countries in the EU now due to Brexit, so we tie it all in together. The current events of the Super Bowl, and a little bit of math with it right there too. And that is today's Math in the News. All right, you ready for some more exponents? Because these are going to be a little bit different, but we're going to work on them in a little bit. You ready for that?
Yes.
Right now we have an opportunity. We're going to head out and about over to Van Horn Elementary and see how they're doing with the Science for Kern Challenge today.
Today we are at Wayne Van Horn Elementary, home of the Hornets, and we are again with Michelle Roy, Science for Kern, with another exciting
Science for Kern Engineering Challenge. Yay.
So, what are we doing today?
Well, today we are going to be doing some investigations around windmills. And we'll be testing to see what sort of blade, what shape of blade, and out of what sort of material will lift the most weight.
Okay, so you're talking materials.
Yes.
So what do you mean by materials?
Ooh, very fancy.
Yes.
We have styrofoam plates, and we have this sort of lighter weight paper plate. Dixie plate, and then a more cardboard, a little thicker, sturdier weight cardboard. And the students will be cutting 3 blades. Three blades. It'll be up to them to design the shape of the blade, and then the blades will go on skewers and onto our testing device over here, which we'll be explaining more about later. And our power source today for our windmill is our very fancy box fan.
Okay, so you've already kind of front-loaded the students a little bit.
Yes,
Can you-
we were talking a little bit about the fact that they're going to need to cut 3 blades. We're going to be attaching them. We have these sample blades that we were messing around with prior to the camera crew arriving, and seeing what the effectiveness was of this particular material. But we haven't spoiled anything for the students. We're going to let them make their own discoveries.
So you dismissed one person from each group, and
Yes.
they chose
And the
material
students so
to use.
far have chosen the sort of material that they want to use. We've had some discussions around why they chose that material, and then now we need to talk about what shape and actually get into the cutting and creating those blades so that then we can build a windmill and test. And hopefully be able to lift some weight. This is the ultimate challenge. The ultimate challenge here is to lift as much weight in the cup as possible, with the wind being our power source.
So you'll be adding more weight and more weight
Yes.
to see
Yep,
which.
to see just how many of the metal spheres we can have in the cup and lift.
Awesome. Well, I'm going to let you take it away.
All right, so let's talk to some students. So over here at this table, would you show us what you selected? And then we want to hear from you. We want to know why, what are you thinking about that plate?
We picked this plate because it was like the most prettiest design.
Okay, and so have you talked at all yet about what shape your blades might create?
They might go in a triangle. We might put them in a triangle or like a rectangle.
Okay, and what purpose do you think that might serve?
I don't know.
Is that what you want to try out just on
Yeah.
for the first try and then maybe modify a bit on your second?
Yeah.
All right, excellent, thank you. All right, so what did you choose over here?
We chose the styrofoam plates.
Okay, and what sort of discussions did you have around selecting the styrofoam plate?
We wanted the styrofoam plate because we thought it would be easier to cut and it would be a little bit lighter and heavier at the same time.
Okay,
And it would be easier to stick the little prongs into there.
so do you have a plan yet for what shape you might cut the blades into?
Kind of like those blades over there.
Like oval shape.
Yeah, oval kind of shapes.
An oval? So can you draw that out on the plate? What might that look like?
Do you want to draw it out?
Like a long oval.
Yeah. And you can actually do it. Oval. An oval.
All right, let's see. Is that going to draw on there?
In the middle. It's kind of large.
All right, so are you thinking more like a flower petal sort of oval shape? Is that what you're thinking?
Like a long way.
All right, well, I can hardly wait to see how that goes. All right, so tell us about what you selected.
We selected this sort of paper, cardboard, because we thought it would be exact same, heavier and lighter and stronger.
And by being heavier, stronger, lighter, what do you suppose that might do in terms of effectiveness once we put it in front of the fan?
It might help it lift up the weights that we have in the example at the table.
Okay. All right, and have you talked at all yet about what shape you might cut your fan blades in?
We might cut it into
Squares.
yeah, maybe some circles, some squares, maybe both. I don't know.
All right, good, thank you. And how about here? Tell us about what you selected.
We selected the paper plate because we thought it was gonna be more powerful. Cause you know how if you throw a paper plate, it goes really far.
Okay. All right, and so what are you thinking in terms of shape? Blade shape?
Rectangle.
Rectangular blades? All right, awesome, thank you. All right, and how about this group over here? Show us what you selected, and then tell us why.
I selected this one because it's not too light or heavy, and it might actually be able to cooperate to lift it up.
All right, to actually pull the weights up.
Okay, so
All right, excellent.
what is their next step?
So our next step then will be to pass out some scissors and actually cut out those blade shapes and attach the blades to the skewers. And then when we come back, we'll actually do some testing and see how our first attempt at windmill building turns out.
Okay, so while they're busy cutting and getting their windmills ready, we're going to send it back to the studio.
All right, thanks for that, Marylou and Michelle, and we'll check out how the kids do over at Van Horn Elementary. Always nice to see in the background when they're in that room, the Do the Math poster hanging up on the wall. So,
Supporters.
nice to see that. We do have phone tutors available until 5:30, but more importantly, we have Anna in studio with us, a 6th grade student from Reagan Elementary, and has been a Reagan Patriot, correct? You guys are Patriots? This is your 7th year.
Yeah.
Getting all ready for junior high next year. Well, one thing that we can do is we can help you out with the exponents. You ready?
Yeah.
All right, we're going to do a little bit more work with exponents since you were masterful with the first few right there. So, 8 KY the y will have a -6 exponent times 7k to the -3rd power y squared. So evaluate that, please.
Oh my goodness, that is a lot of stuff. So we just went from just simple little numbers with a couple exponents to some numbers and some letters and some negative. We got lots of stuff going on here. Where do you want to start with this?
The ky -6.
Okay. Tell me this. This is always a good place to start. I like to start with my students too, and I think this is a good place to start. Like you said, ky to the -6. What is the exponent on the 8?
1.
1. I'm going to go ahead and write that in there for you so we don't forget. What is the exponent on the k?
1.
Good for you. So this -6 only applies to the y. That's a really important thing to do. Can we keep going here? What is the exponent on the 7?
1.
What's the exponent on the k here?
-3.
So that's going to be okay. What's the exponent on the y?
2.
Good. So now we have exponents for every single individual piece of this problem, right? I think that'll be good for spreading it out. Okay, let me see where we're going to go next.
To the k to the -3rd power.
Gotcha. So you want to go ahead and make yourself a fraction?
Yeah.
Okay, make a fraction bar. Okay, so you change that one. Are there any other negatives?
Yes. The y.
Good. Okay, so we have changed those ones to have no negative exponents. Good start. What's next?
Keep going.
Squared.
Now, when you put this y to the second next to this fraction, what's happening there? What's the operation?
Multiplying.
Multiply. Gotcha. Okay, just wanted to make sure you knew that. And we can go ahead and put a little dot in the middle so we don't forget that either. Okay, so we have 8 and k. Is this a multiply as well?
Yes.
Okay. And is there anything else that we're leaving out? Have we used all the terms there?
Yes.
Look real close. What are we leaving out? We want to make sure we don't forget anything from the top line. We got the 8, we got the k, we got the y to the 6th, -6. What's next?
Oh, the 7.
I don't want to forget the 7. All right, good. So there's a good start. All right, so now we have all positive exponents, which is definitely a direction we want to go. What's next?
To multiply.
Okay, let's multiply them. Good idea.
So 8k times 1 over y, so the 6th power is times.
Okay, so you got 8k times 1 over y to the 6. Good. I just want to hear, speak a little bit out loud so we can kind of know what
Okay.
you're doing here. Got 7.
And 7 is also being multiplied by 1 over k cubed. So that's multiplied by y squared, so it's y squared.
I like how you wrote it. Now, if you look up here and look down here, they're pretty much the same. This is a little bit nicer writing. Okay, nothing wrong with that at all. So what you've done is not wrong, but we haven't really simplified much. We haven't really made it much simpler. So the next step, I'm going to suggest, let's go ahead and make this as simple as possible, okay? And let's do this. I think this is something you can do. We're going to make this part right here into a fraction. And we're going to make this part right here into a fraction, and then we'll multiply them together because it says multiply in the between there, right? Okay, so which things go on top and which things go on bottom of the first fraction? What goes on top?
The 8.
The 8. 8 goes on top. Go ahead and write that in there. And what else goes on top?
The 1.
The 1 can go up there, but 8 times 1 is still 8, right?
Yeah.
Any other letters going to go up there? What about that k? What's the exponent on the k?
1.
Gotcha. So that's going to stay on top, right? That's a positive. So go ahead and put the k up there on top. Good. What about in the bottom? What goes in the bottom of that fraction?
Y to the 6th
Good
power.
for you. There you go. So y to the 6th. So what we've done is we've kind of combined this part right here. Anything that had a power of 1 is going to stay on the top, or a positive exponent. Anything on the bottom there, we have y to the 6th on the bottom. Let's do the same thing for this fraction here, okay? So what goes on top? 7, right? Yeah. Talk out loud. Tell me what's going on here. You got a 7. That's here.
And the y
And the y to what power?
to the
Good. Second power. What goes in the bottom?
k cubed.
Good for you. All right. So far, so good. We're going to need more room, huh? Dang. It's getting to be a longer page, but we're going to have some fun with this one. All right. So now when you multiply fractions, what do?
You You can cross multiply.
You could cross multiply. What else could you do? Can you put them all in the same fraction?
Yeah.
Yeah, you could go straight across and simplify later, or you can cross multiply. Do you want to do some cross multiplication?
Yeah.
Okay, let's see what you can do here. I'm interested to see you do this.
You can cross out the k's.
Okay.
And since these are 3 k's, you can cross out one of them.
Oh, I like how you expanded that. That's a great idea. So this k to the third is really 3 of them, and you cross that one and that one. Okay, keep going. Thanks for explaining that. That makes sense.
There's 6 y's.
Got a whole bunch of y's in there. Okay. So we got 6 y's here. That's what it says here. And how many up there?
2.
Okay.
So you can cross out these 2 with these 2.
Gotcha. All right, so we made kind of a mess there, which is totally okay in math, right? I love it when students make a big old mess out of their paper because it means they're working hard. So you're working hard here, and nothing has gone poorly yet. We've really done some good work here so far. So let's see if we can start to clean it up, though, okay? What are you going to do next now that you have some of the letters gone?
I'm going to rewrite the problem with what I have left.
That's a good idea. Let's do that. Go ahead.
So 8.
Okay, so the 8 still stays there. Good.
Over 4. Y to the 4th power.
Gotcha. So you only have 4 of those 6 left. Good start.
Times 7 over k squared.
Gotcha. Where did the y's go up here? Are they gone? Oh, we crossed them off there.
Yeah.
Good job. Looking pretty good so far. Now, do you want to put them all together again? Put whatever we have left together?
Yes.
What do you do now?
So 8 times 7 is 56.
So now we can finally multiply those fractions together, huh? 56
Yes.
over.
4 times 2. Wait, so it's 4 plus 2?
Well, tell me a little bit about that. What are you trying to do? You're trying to put those
So-
exponents together?
Yeah, when you're multiplying.
Tell me about the bases in these problems. Are the bases the same? What's the base of this term right here?
Y,
What's the base of this term?
k.
Can you put those together?
You would write y, k.
I like your ideas. Okay, good ideas. I like it. And we're definitely going to put yk, but let's make sure we put in some exponents first. What's the exponent on the y?
4.
Good. Keep the 4 there. Now write your k. And what's the exponent on the k?
2.
That is a lot of work. But it's so much simpler than if you go back all the way to the top here. Look how crazy that was. And then we got all messy. We got to make it even messier and messier, but at the very end, it comes down nicely to this little fraction at the end here. And that's how you simplify. I like how you drew them out and crossed them off. I think it's a good way to look at it physically to actually see how many you cross off. And then at the end there, put them all back together. Nice work on that problem.
Yeah, I was going to say, by expanding that, it's going to make it a little bit easier to look at that and understand what's going on.
Definitely.
Instead of trying to do it in your head, where after a while you can, but doing this makes everything a lot easier first, all right?
Yep.
New board, new problem.
All right.
This one, not as detailed.
Okay.
8b, as in boy, times 6b to the negative 5th power.
Okay, so we're going to use what you learned last time, and I'm just going to stand here and watch you do this one because I think you can.
Okay, so
Okay.
we're going to have to turn that into a fraction because we can't have a negative exponent. So it's going to be, since we have 6, it's going to be 6 over b to the 5th power
I'm still going to cheer, even though I'm not doing anything. Good job. That's a great start.
times 8 over,
That's okay. You can make it into a fraction if you want to, but okay, I see what you're doing here. Go ahead.
times 8b.
Good. Okay, what do you want to do now? Now,
Okay.
if you were going to make this into a fraction, sorry, I'm not going to do it. I'm just going to ask you. If you were going to make 8b into a fraction, how would you do it?
8b over 1.
Okay, you want to write that? So then we have two fractions together, kind of like the last problem? Okay, there you go.
So then this would be 5 b's. And then this has 1 b, so you can cross out 1 with 1.
Gotcha. So you're doing some cross multiplying again.
Yes.
Okay.
And then you could do, so that's going to be 8 over 1 times 6 over b to the 4th power.
That's it. I'll give you a little bit more room to see if you can finish up. 8 over 1 times 6 over b to the 4th.
So then you can multiply the top now because we have 1 over here, so
Okay.
that's going to stay the same. So it's going to be 48 over b to the power of 4.
Nice job. Yes, getting a lot quicker on that one too.
There you go, perfectly done for
Yes,
some
sir.
great exponential problems. You got yourself a meal courtesy of our friends at Broken Yolk, so congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. We'll be back with more right after this. Today we're at Blake School, and we're here to And we're back once again at Blake School with students in 6th, 7th, and 8th grade talking about numbers, first of all, place value, and then number patterns. So here on the 100 chart, you can find a lot of different patterns on that 100 chart, right? What's one pattern you might see on there right now?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5, 6, right? Okay. Take a look at going down a column.
2, 12, 22, 32.
So what are they doing?
Adding.
They're just adding 10 every time, right? So there's a lot of patterns that you can find on a 100 chart, right? You could look at it diagonally, right? There, you could look at the corners. You could look at just the ends. There's all sorts of different things you could look at and find patterns on that paper. So in each of your pairs, you have somebody's number that you're looking for. And there are 6 clues on that paper. What you need to do is you need to look at all 6 clues and use your 100 chart and see if you can figure out what that person's number was. All right? So you guys have Paul's number, right?
Yes.
What's one clue? Read the first clue on there.
Paul's number is not located on an edge or a corner. Help your group find Paul's number on the 100th.
Okay, so it's not on the edge or a corner, correct? So what numbers can you get rid of if it was your group right now? What would you do with the 100 chart? Yeah, what do you want to do?
You wouldn't have any of the sides.
You would just cross those out, right? You could just draw a line right through the sides and the corners, right? So the 100 charts are for you guys to work on, all right? What about you guys? What's the first clue on yours?
The sum of the digits of Meg's number is greater than 10.
So you know that when you add the 2 numbers together, that number is going to be larger than 10. Now, let's take the first number larger than 10, 11. If we take 1 and 1, what does that add up to?
2.
2. That can't be the number 10 because it's not larger than 10, right? What about 23?
That's 5.
That's 5. That can't be it, right? So you know it's not going to be anywhere around there. You're going to have to think a little bit higher on that one.
Any teens except for 19.
Right. So go ahead and keep working, right? It has to be larger than 10 and look at all the clues, all right? What about you girls? What's the first one?
His number is a multiple of 3.
So it's a multiple of 3, right? So if you know your multiples of 3, 3, 6, 9, 12, 15, and you just keep on going, you know it's going to be one of those numbers, right? So if you guys wanted to, you could go like, all right, like circle 3, circle 6, circle 9, 12, right? And then start doing all the clues and condensing them. See if you guys can find out what the number is, all right? Go. You guys think you have the number?
Yes.
Paul's number. What do you think Paul's number is?
29.
What is it?
29.
29? Read the clues and let's see how the clues work out.
It says Paul's number is not located on an edge or a corner.
Okay, so 29 satisfies that.
It is not an even number.
29 is not an even number.
The difference of the digits in Paul's number is 3. We didn't look at that one.
So the difference in 29 would be 7. So the number, you're getting close.
We'll have to find a different one. So we gotta think, Dahlia. The difference has to be 3, but the sum has to be 11. All right.
So the difference is 3 and the sum is 11. Did you guys find your number?
Yeah.
What is it?
84.
Whose number were you looking for?
Meg's number.
Meg is 84. Read the clues quickly.
The sum of the digits of Meg's number is greater than 10. The difference between the two digits of Meg's number is greater than 3. Meg's number is a multiple of 7. The first digit of Meg's number is larger than the second. Meg's number is not odd. Both digits of Meg's number are even.
And 84 satisfies all of those things. Congratulations. Did you guys find your number now?
Yes.
Which number is it?
I think it's 47.
47 is correct. Nicely done. You guys still working on Tim's number, or have you got it?
Yeah, we're
Still working on it? All right, continue working. We've got the 6th, 7th, and 8th grade students looking at number patterns and figuring out what the number is at Blake School. A big thanks to the staff and students at Blake School, and if you're in Kern County in Bakersfield and want a nice little drive for an afternoon, head on out to Woody. A wonderful drive that is. Very scenic, and especially right now, everything is nice and green, things like that. So a nice drive out there, a wonderful place out at Blake School. We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. We have 6th grade Reagan Elementary student Anna in studio with us. And Anna has been working on exponents, so she'll do a little bit more. But first, we're going to head back out to Van Horn and see how they're doing with Science for Kern.
We are back here at Van Horn Elementary, home of the Hornets. And again, I'm with Michelle Roy, Science for Kern Engineering Challenge.
Ooh, yes.
Okay, take us where we're at right now.
Well, so the students now have all cut out blades, and they've taped the blades onto their skewers. And so we're ready to have the students come over to our testing station and actually test out the blades. Put some wind, got our power source over there, put some wind to our windmill and see if it will indeed lift our weights there. And hopefully, by the time we're finished, that maybe we can even lift a whole cup
That's going to be
of
exciting.
metal spheres. So my group over there that I was talking to right before we came back, come on over, bring your blades over. And so let's stick this one in here. You want to stick one in there? Where do you want that one? All right. Stick that one in there. Okay. Bring that one over too. Come on over. Let's stick that one in. All right. So are you ready?
Wrong way. That's the wrong way.
All right, let's see what happens. Let's turn on a bunch of wind here. All right. So not much is happening. What do you think that you might need to just change right now about the blades? Because we talked about this right before we went back on camera. Can you do something just to the way it's set up right now without pulling any of your blades out? Go ahead. Try something.
Spin it. Something.
What is your thinking?
What did you do?
I changed the direction, the direction.
The position of the blades? All right, so we're not lifting though, right? So what do we need to change now? All right. All right, so let's have another group come up.
I know why.
Let's have the group back there in the center. Bring your blades over. And let's see what happens. All right, so let me stick the first one in. All right, so who's next? Do you see the hole right there? Stick it into what's already there. All right, one more. All right, so what do you think is going to happen? Step back so we're not, there you go.
It's going to spin that way.
All right, so what do you need to do to your blades to get them to spin? So why do you suppose that's making a difference? Because now we still don't have anything happening. What do we need to change now? Somebody else can step up and try something. Are you guys watching and learning over here? Yeah, all the other groups, are you watching what's going on here? You guys think of a plan? Yeah. All right, so do we have any spinning yet? All right, almost though, right? So what else do you need to change to get it to spin? You think it's the shape of the blade itself? What do you think? All right, so I'm gonna let you guys try. You can take those back. Why don't you guys hop up here real quick? Make sure it's going to stay together. All right. Stick those in sharp end. Try it out there and let's see what happens.
Okay. So
All right.
as this group is trying, and we have one more group to attempt it as well, they're going to keep on working, but we're going to send it back to the studio. When you come back, they're going to have made adjustments, and we're going to try another
again.
test. All right, back to the studio.
All right, thanks for that, ladies. And we'll see if we can get a couple of better buzzers in there, instead of the gongs and stuff, whatever. Anyway, we do have phone tutors here until 5:30. We have Anna in studio, been working on exponents. You evaluated exponents, you multiplied exponents, so now we're going to divide with exponents. All right, over to the board, young lady. So these are two problems that you have on your homework, and you said these two you want to take a shot at, all right? So here we go. 9y squared over 7y cubed r to the 5th. That's it.
What are you going to do with that?
I'm going to subtract these two because we're dividing.
Which ones? Subtract what from what?
3 from the 5.
Oh, gotcha. Now tell me again about the bases of those two things. What's the base on this term right here?
Y.
And what's the base on this one?
R.
So we can't really put those together, right? You know what? One of the skills that you have that I really, really like is drawing out the problem. Okay, so I think that really helps a lot. So here we go. We're going to draw this all out. You said earlier in the show that you know how to do prime factorization, right? You know how to break numbers down. So break down 9. What numbers would that be if you broke down 9?
3.
3 times
3.
Good. So you broke down 9 also, right? Let's break down the y to the second power.
Y times y. Whoop.
Y times y. Good. Now do the same thing on the bottom. Okay. Can you break down 7?
No.
Okay. So you don't have to worry about that, but at least put down 7 so we don't forget it.
7.
And then how many
y
y's? Good.
Times y times y.
Yeah. And then what about the r's?
And then that's times r times r times r times r times r.
All right. Now here's what I always tell my students. This takes a little tiny bit longer. Not too long, right? Your hand hasn't fallen off, so that's good. It doesn't kill your hand too much. It takes a little tiny bit longer, but if you do this on every division problem with exponents, you will never get it wrong because you can see all the pieces. Now, what can you cross off?
These two y's
Yep.
with these two.
That's it. You can see them right there, right? Your top and bottom. We're going to go here and we're going to go here. You can cross them right off. And then all you have to do in the very end of the problem is put everything back together that you didn't cross off. So we're going to make one last fraction for our answer. What's left on the top? You can multiply it back together again.
9.
9, good.
And then 7r to the 5th power.
Gotcha. Look and see if you forgot anything. We got this 3 and we got the 3. We got that, right? We got the 7. That's good. What about this one?
Yeah.
Oh, yeah. We don't want to forget that. Now, does it matter that you put the y at the end or in between the 7 and the r? Could you put the y at the beginning?
Yeah.
You could, because being multiplied, right?
Yeah.
In fact, I would suggest to you that this is actually a better answer than if you'd have put the y before the r, because a lot of times when a problem in math has multiple variables, more than one letter, they will put them in alphabetical order. And so you'll have the number first, like 7, then you'll have the r, and then whatever power that happens to be, and then you'll have the y. The last thing I want to tell you about this is the reason that I think it's a great idea for you to break down that number 9 on the top. Let's say that instead of, right, we're just going to do this hypothetically. Let's say instead of 7, it was a 6 on the bottom. What are the two numbers that multiply to be 6?
3 and 2.
That's right. So it would actually be 2 times 3, right?
So then you can
And
cross
then you
out.
could cross off the 3's. And you could see, you could actually do your reducing before the end of the problem, and you could reduce it just like you cross out the letters. So keep that in mind. Even though it takes a little bit longer, you can reduce the numbers and you can reduce the letters if you draw it all out. And you can see a picture of what's being crossed off. All right, are you ready for another one?
Yes.
So
Here we
there's
go.
one waiting
Clear
for
the
you.
board. I've got one more for you.
Yep, here we go.
And this just happens to be on your homework, but since Kansas City won the Super Bowl, it is KC over 5K to the negative 6th.
Could you try again?
I will try again. C to the negative 5th.
Wow, there's all kinds of stuff going on there. Okay, let's see if we can use what you learned last time, break it all down, and make a new fraction. I'll even write that fraction bar for you there.
Well, you can't have negative exponents.
You don't like those, huh?
So you're going to have to turn those into fractions.
That's true. Let's start at the top, though, okay? Because you're exactly right, and we will get there soon, but let's not get too far ahead of ourselves and start at the top. K, what's the exponent on the K?
1.
Okay, what about the C?
1.
Okay, and so where do they go
On the top.
on our new fraction?
On the top.
On the top, put them up there. Good, so we got K and C, so we've done that one and that one. Now what about the 5? What's the exponent on the 5?
1.
1, okay, so where does the 5 go in our problem?
On the bottom.
On the bottom, go ahead and put the 5 there. So all those things didn't move. Nothing moved there yet at all, right? Now you said we got to do something with this K to the negative 6. What are you going to do with that to make it a positive 6?
Turn it into 1 over K to the 6th.
And it was already on the bottom, right? So really what this is like 1 over K to the 6th on the bottom of the whole fraction. That's kind of weird, huh? Okay, what about the C? We'll figure this out in a minute.
1 over C to the 5th power.
That's it. Now we have something that really tends to freak people out. We have fractions in a fraction. And we don't like to do that because it really throws people off. How are we going to fix that? Any ideas?
No.
Okay, well, how about this? I like the fact that when you talked about negative exponents, you said to make it into fractions. It's exactly what we do, okay? Think of it this way, though. This is a little bit different perspective. What you're doing is you're taking this K to the 6th power and you're moving it, right? Like if you said this was the top, you're moving it to the bottom of the fraction.
Yes.
If the negative 6 or the C to the negative 5th, if that actually starts on the bottom, then all you need to do is
Leave it there.
move it to the top to make it positive. So the negative means you just have to move it. If it's already on the top, you move it to the bottom. If it's already on the bottom, you move it to the top. So these are not wrong, but we're going to see if we can change these up a little bit and just look at the fact that K to the negative 6 is on the bottom. Where will it go to make it positive?
To the top.
To the top. Move that to the top if you could.
So it'll be K to the 6th.
Mm-hmm. And what about the C to the negative 5th?
C to the 5th.
Wow. So now at least we have a fraction with no negative exponents, which is kind of our goal, right? But you can tell we have a little simplifying to do at the very end, right? All right, what are you going to do with this?
Well, you can subtract the two. You can combine the two exponents and subtract them because we're dividing.
What goes on the bottom?
5.
5, good. How many K's do you have here?
2.
Not right here.
Oh, 1.
K, right? And then you also have a C. After that, can you draw out those 6 K's for me real quick? Because remember, it takes a little bit extra time, but you won't get it wrong. Good. Yeah, 4, 5, 6. Good. What about the C's? Be quick on the C's. Here we go. And a 1, and a 2, and a 3, and a 4, and a 5. Can you cross off anything from the bottom at all?
No.
No, you can't. So let's do this. Let's squish them all back together, okay? Took a little bit longer. We're going to have a fraction. You're going to have 5 on the bottom. Squish them all back together. First of all, which letter comes first in the alphabet, K or C?
C.
C. So let's count up all the C's. How many do you have?
6.
6. Go ahead. C to the 6th power. Good. How many K's do you have?
7.
7. And I love it when you draw it out like that because then all you got to do is count them up. That is the simplified version of that problem. Well done. I like how you
Excellent work, Anna, right there. And by doing this, I think it's going to help you in the long run when you start doing these a little bit more often.
Yep.
All right, we do have phone tutors available until 5:30 this afternoon for some great work right there. Anna's just got herself a meal courtesy of our friends at Chick-fil-A. So congratulations on that. One of the things that always happens in Kern County is there's a career expo going on, and we do have one coming up.
And look around, look up, down, you can see get a sense of how big the space is going to be.
There's no better person to learn about a job from the person who's doing the job.
Go back here, you can see the weld.
Close to 150 different employers here from a wide range of pretty much every industry sector covered. And so the opportunity for kids is find out about jobs they probably didn't even know existed in their communities.
Bolthouse Farms, Tasteful Selections, there's an Amazon Fulfillment Center coming. Anything that deals with automation, our program and all the programs at BC are very focused on. They're excited to see this kind of technology and they can learn it in their middle school and high school area, finish the degree at Bakersfield College and go off and have a wonderful career dealing in automation.
These are students in our community, and that's what we're looking for. So, you know, she is just getting into college, but in 4 or 5 years, she might be working alongside me. And so having that interaction and making those impacts when they're this young, it's really advantageous for our company. Look at those qualifications now, so that way as you go through school, you know what you're working towards, right?
You got that on your legs.
When you take an aptitude test or a bubble test, it's not really real, but these people are showing the kids and showing their parents that you can in fact have a job in whatever particular area that you're looking for.
So let's talk about those middle school students or those freshman students who've never really understood the different opportunities out there in terms of careers. When they come here, they get a chance to be exposed to things that they've never seen before.
I personally like engineering, so that looks very interesting to me. A virtual reality system, I've not seen anything like that, or tried anything like that. I have some new ideas.
Between our high school districts and our unified districts, between our community colleges, our industry partners, and our nonprofits, we're all here together collectively.
Just watching the kids, they're excited, and I just watched a young man over here grab his dad's shirt and say, hey, let's go over here. That's pretty neat.
And once again, we have Anna, a 6th grade student from Ronald Reagan Elementary, working on a lot of exponent problems today, but you already had an opportunity to go to Camp Keep, correct?
Yes.
If somebody says, hey, I'm getting ready to go to Camp Keep, what's one thing I should know? What's one thing you would tell them about Camp Keep?
Lots of hikes.
Lots of hikes. What's the thing that you liked most about Camp Keep?
The types of hikes they had.
So you like going on the different types of hikes and things like that, right? You like going down to the water and doing that, what is it, the belly biology or whatever, where you're on the dock and looking underneath and stuff like that? All right, well, we'll see if we have a little more time to talk about that. But first, I need you to do one more exponent problem. You ready? All right, over to the board. 4w to the -4th power, k to the -2, that is all over 3wk to the -3rd.
Oh, wow, I like that one. Okay, go get them. Remember, draw it out, right? Make it look good.
Yes. So there's 1, 4, and there's,
So here's our new fraction, right?
Yes.
Where's the 4 go?
The top.
Okay, keep it on the top. Where's the w to the -4 go?
The bottom.
Okay, so when you put it on the bottom, let's go ahead and draw it out, okay?
So it's W times W times W times W.
Good, there you go. What about the k to the -2? Where does that go?
On the bottom.
Okay, and draw that out when you put it down there as well, okay? Good, we're gonna make this, yeah, exactly right. We're gonna make that line a little longer. It's okay to make it longer. All right, how about the 3? The 3 is on the bottom.
Yes.
Where does it go from there?
Still.
It stays on the bottom, good for you. What about this W? What happens to that one?
Stays on the bottom.
Stays on the bottom, good. And what about the k to the -3?
Goes on to the top.
Good for you, okay, draw it out when you get it up there. Draw it Okay, now we can see which things get crossed off. Can you cross anything off with the 4?
No.
Nothing to cross off there. Let's head on to the K's.
You can cross off these 2 with these 2.
Okay. Anything else at all? If you broke down 4, what could we write instead of 4?
2 times 2.
There you go. So then we know that everything's broken down. Can you cross it off with anything on the bottom?
No.
We can't. Didn't hurt anything, but it was nice to be able to know that for sure we have everything broken down, right? Okay, so now that we have everything broken down and crossed off what you could, go ahead and squish it all back together. What's left? On the top.
4K.
4K, good. On the bottom?
Over
Let's do the number first. What number do you have on the bottom?
3.
3, good. And then you're going to do K's or W's first?
W's.
W's. You don't even have any K's down there anymore, do you?
Yeah.
How many W's?
5.
Good for you. That's it. Do you have any negative exponents in your answer?
No.
Are the numbers reduced?
Yes.
Gotcha. Are there any other letters that you need? Do you need any more W's up here or K's down there?
No.
If you had them, we could cross them off, right?
Yes.
Nice job. Always good to do a little check at the end there. Well done.
There you go. Nicely done, Anna. Thanks for that work today. So you've done a lot of work with exponents, evaluating, multiplying, and dividing. Hey, we do have one last opportunity. We'll go see how the kids are doing at Van Horn Elementary and at Science for Kern.
We are back here at Van Horn Elementary School, and we are with Science for Kern Engineering Challenge, and it has been quite a day.
It has been. We've tried all sorts of things and lots of learning going on today. Even in failure, there is learning.
Yes. So we've already tested everybody at least once with their fan blades.
Yes.
So now we're into the second test.
Correct. This group was up earlier, and this is their second attempt at a different design of blade. So ladies, can you tell us a little bit about how these blades are different from what you tested earlier?
They're different from what we tested earlier because before this was flipped that way, so we changed it. So we changed it and flipped it the opposite way that it was before, and then put more tape to make it stronger.
Okay. All right. And so you're thinking that more tape. So why do you think that this design might be better than what you had before?
Because it'll like help it more. And
how so?
Like probably it will make it much stronger.
And probably like the wind will come right here and make it fly more.
Okay. So you want to test?
Yeah.
Is that going to stay together there? Let's make sure it's taped on there. All right, that feels secure to me. So is this the angle you want the blades at?
Yeah.
Did you get a little tilt, a little bend in your angles there on your blade? All right, well, let's see what happens. Is it going to turn? Huh. So, do you think if you rotated your sticks at all, maybe, so that they were at a different angle, that it might spin? Where'd you pick your angle? It's trying, isn't it? Watch out there. Watch, make sure you're not touching the stud.
Try this way. But if we go this way, it will make it just go looser. We have to make it go that way so the cup will come up.
It wants to go. All right, so we almost had success there. Is there another group that would like to try?
Yes, right here.
Do we have another group right behind me? All right, thanks, ladies. All right, tell us a bit. All right, here we go. We're going to pull this right out. All right. Stick that through the straw there, and let's see what happens.
Oh, this is not in the right direction.
You want to move that one a bit?
I can't get it on top.
Do you want me to help you? Yeah, it's kind of hard to stick it in there. Look at that! Woo! wrong direction, but yay, we actually spun. All right. Way to go. This was success. So why do you think that this particular design worked? Okay, so tell us a little bit about your thoughts on why that design.
You're a genius. Because I put oval shapes at a certain angle.
All right, so what's the difference between your oval shapes? Why do you think your oval shapes spun and the shape that the ladies that tested right before you, theirs didn't? What's the difference?
The wind did not get them at a certain angle.
Okay. Excellent. Thank you for sharing. Way to go. Well done, group. All right, where's our next group? All right, let's see what happens. All right. That's trying so hard.
When you try,
You need to make any adjustments.
Rotate the blades a bit, you think? Almost.
Do you think you need to, looking at the tape side is facing the fan?
Do you think
we think that would make a difference?
Let's see what happens.
Try to turn down. We're not trying to. Does that make a difference? It just wants to go. It's fighting it.
Yeah, what if I wonder if we took, let's take the cup off and see what happens. See if it'll spin now. Look at that.
Well, it's almost there. This has been a lot of fun today.
We learned a lot about wind and how wind passes over blades and the angle of blades. And yeah, if we had more time, we'd certainly be able to get at a better solution.
Yes. Did you guys have fun today? Yeah. Okay, so as we continue to test, but that's all that we have
all
for
for
today. So that's it. Thank you again to Van Horn Elementary for letting us come and do the Science for Current Engineering Challenge. And again, Michelle, thank you as always. Wonderful. That's it. Back to you, Mike, at the studio.
All right, thanks for that, Marylou. Thank you to Michelle, and thank you also to the students at Van Horn Elementary, home of the Hornets. Well, we do have phone tutors available until 5:30. We want to say thank you to Anna for coming in. You knew a little bit about exponents. Did you learn some more about them today?
Yes.
All right, so I helped you out with your homework a little bit, right?
Yeah.
Good. Did you have some fun today?
Yes.
Good. And we made your brother work while he was sitting over there in the stands also. Hey, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.